Hello everyone, welcome to part 13 of my video series on probability distributions. So today we are going to discuss about the geometric distribution. So without further ado, let's dive in. So let's start with an example. Suppose I just opened my YouTube channel. The question is, what is the probability of getting my first subscriber from the 10th viewer? Let's understand this question in a bit more detail. This means that the first 9 viewers did not subscribe to my channel. That means they are all failures for my case. The 10th viewer subscribed, and that is a success. Total number of event was 10. So basically, we had to have 10 viewers before we received a successful event, which is the subscription. So if we assume that the probability of subscription success is P, then the probability of this entire scenario happening is going to be 1 minus p to the power 10 minus 1 into p. Let me explain. That means the first 9 viewers did not subscribe, so they are failures. So that means the failure probability here is 1 minus p, and it happened 9 times, so it is going to be 1 minus p to the power 9. Now I have written this as 10 minus 1 because x is equal to 10, total number of event is equal to 10. Then we have a p as multiplication because the 10th event was a success, right? The 10 viewers subscribed. So this is how the probability looks like. So this is the general formula of the geometric distribution. So exactly this scenario is going to be modeled by geometric distribution. So what geometric distribution tells you is this: what is the probability of x number of events until you get your first success? That means PMF of x, probability mass function of x, where x is the number of events until first success, is going to be 1 minus p to the power x minus 1 into p. And x can be any number, 1, 2, 3, 4 up until infinity. And they are all integers. That means this is a discrete probability distribution. One more thing, you may be wondering why x cannot be 0. It is because if there is 0 event occurring, then obviously there will be no success or no failure. That is why x starts from 1. So if we say x equal to 10, that means on the 10th event, there will be a success and the previous 9 were failure. So this is how the probability mass function plot looks like when probability of success equal to 0.1. That means only 10% success rate. That means the probability of the success occurring in the very first event is not that high. But gradually, if you look at right here, the probabilities are much lower. This is because intuitively you can see that even if the probability is 0.1, it is very likely, that the first success would have occurred much earlier than 10 or 11 events. That is why the probability values coming later on are actually quite low. So let's also see what happens if we increase the probability of success to 0.5. In this case, you can see it is much more likely to get the success in the very first few events. But as we go to more number of events, we have already reached the success. That means you can see that the probability of getting the first success after 10 events is actually quite low. This is because we're expecting that the successful event should occur much earlier somewhere right here. So if we increase the probability even more, you can see that the successful event should have occurred in the first 2 or 3, not even 3, I would say, first 2 events basically. And in the rest of the events, we have already succeeded, so they don't really matter. So what is the expected value? We know that x starts from 1 and goes to infinity. So we are going to have to take the summation of that from x equal to 1 to infinity. So these are the number of events. And x is here, x into the PMF. So this is the PMF, this whole thing. So you know that ex is equal to summation of x px. So px is this whole thing for the geometric distribution. And it is going to be 1 by p if you do the math. Now what does this mean? This means that if you have a higher probability of success, that means if p is large, then there will be lower number of expected events until success. For example, if p equal to 0.1, then this expected value will be 10. That means we can expect that after 10 events, we are going to get a success. But if p is a much higher number, say 0.9, then you can see that 1 divided by 0.9, it is 1 point something. That means we should get the success within the first two events. So what is variance? This is the formula for variance. So we just put x square right here and the same formula right here of the PMF. And also 1 by p is the value for ex, the expected value. So if we do the math, we are going to get something like this. Now here, if you make p small, if you make the probability of success small, you are going to see that the variance will increase. That means with a smaller p, we are going to have more uncertainty in the number of events required until success. And this is actually true because let us actually see the plots again. You see that when we have a high probability, the variance should be quite low because we are pretty much sure that in the first one or two events we are going to get the success. But when we have a lower probability value, the success can happen at any time. That is why the variance is much higher. So that is the variance. Finally, we have the cumulative distribution function. So what is that? Basically, we are now asking this question of probability of x less than equal to x. That means probability of getting the first success within x events. So suppose if x is equal to 5, then the success can happen within one event, within two event, within three event, within four event, and within five event. So that means we can get success in 1, 2, 3 up until x event. So we have to add all of those things up. So probability of x less than equal x can be written as 1 minus probability of x greater than x. So what is probability of x greater than x? Probability of x greater than x means that we require more than x number of events until success, right? Which means the first x events will result in failure and then in some event we are going to get a success. So what is the probability of the first x events resulting in failure? It is simply 1 minus p to the power x because 1 minus p is the probability of failure. That means we can simply substitute 1 minus p to the power x right here, and this is going to be our formula for the CDF. So that's all about geometric distribution. If you like the video, feel free to subscribe and share, and you can donate to our channel through the link in the description. Thank you very much.